Hello, in this short video, I'd like to show you a few total product curves. This one came from the game we played in class with the widgets, the production of widgets, which was basically to fold a piece of paper twice and to staple it with a stapler. And we measured different, we had the different amounts of labor, and they produced different amounts of widgets within 1 minute. And in the one section, we got a production function that was concave. It was increasing at a decreasing rate throughout. So this is the total product curve. As you increase labor, production increases, but it increases at a decreasing rate. Okay, throughout. In order uh, to to find the average and marginal product of labor, you look at the for marginal product of labor, you look at the slope of the total product curve. So there's the slope of the total product curve at L0 units, and then there's the slope of the total product curve at L1 units. So if you transpose this down here, you get L0 units, L1 units, and you can see that the slope here is much steeper, so it's a bigger number in absolute terms relative to the slope here, which is a smaller number in absolute terms. And in fact, if you go to L2 units of labor, you'll find actually the total product, the marginal product of labor is 0. In other words, the total product has maxed out. Okay, so marginal product is 0 at L2, and it's very high at L0, and is somewhere in between the L2 and L0. Let's say here, L1 units. Okay, so you can see that the marginal product of labor declines throughout, and it declines pretty fast, and it could go even negative. Okay, so there's marginal product of labor. Okay, which shows you the additional output produced from an extra unit of output at the margin. Okay, so a little bit extra L0 units produces this much additional output given by the slope of the linear line tangent to the production possibility frontier, and you can draw more and more, and you'll see basically that all these lines that are tangent to the total product curve decline throughout. Okay, in order to get the average product of labor, and I'll do it for L0, L1, and L2 units, you draw a line that is from the origin linear, and it goes right through right through the units that you want to measure average productivity. The slope of that is the average productivity of labor. So there's average productivity 0. Okay, and in order to draw this one, you draw a linear line going from the origin up there. And I don't have to do it all the way, but you can see that the average productivity here has fallen, and it's steeper than the marginal product, so it's much higher than the marginal product. And also you can see it here. There's average productivity. The average productivity is way above marginal productivity. Marginal productivity is 0, average productivity is positive. But you can see that it also declines because this slope is steeper than this slope here. So average productivity would be above marginal productivity, and it would decline also. And there's average productivity, so average productivity and marginal productivity decline. Also, since marginal productivity is below average productivity throughout, then that pulls down average productivity. Yeah, that's it. That was fast. Okay, in the next little video, I'll show you the different type of. Oops, come on up, come on up. So in the next video, I will show you the derivation of a different, slightly different production function and its relationship with of average and marginal productivity of labor. Thank you. Bye.